Alright, in this video I want to take a look at Newton's method and see what could go wrong. Newton's method, when it works, generally works pretty well and pretty quickly, but sometimes things go wrong. And here's one thing that could happen, a couple things that could happen. One is, let's say I've got a function like this and I'm looking for the x-intercepts here, and I'd say, well, I'm gonna start with my initial guess at 0 because it's an easy one to work with and it seems to be closer to this than that. So I'm gonna try this one. I'm going to be looking for this. So I plug a 0 in and I draw the tangent line, and the tangent line comes over here and hits out here somewhere. Okay. And so then this is going to be my second guess. And I plug it in and I draw the tangent line. I'm going to turn this a little bit here so I can get a good angle on it. And I draw the tangent line, and the tangent line comes down and it hits over here. And so then you plug it in, and all of a sudden this tangent line is hitting over there, and then the next one is hitting clear out here, and then the next one is hitting there, and then actually that was a bad drawing here. So then the next one is here, and so then that it's there, and then here. Anyway, at this point it's going to zoom in on this one. So initially, what I thought might zoom in on this actually spiraled outward and ended up finding this other one over here. Other things that go wrong, in fact, I think I mentioned this in the first video. One thing that could happen is, you take your first guess and it puts you right smack dab at a maximum there, or maybe a minimum, where the tangent line is horizontal, and that tangent line never hits the x-axis, and so it fails to return a result. In that case, the Newton's method wouldn't work. You'd have a place where you're trying to divide by 0, because remember, you're always dividing by the derivative. And if you hit a spot where the derivative is equal to 0, then Newton's method won't give you a next answer. Sometimes what happens is you don't zoom in on anything. Sometimes you get this thing like this, and you say, okay, I'm gonna plug in a value here for my initial guess. You look at the function value, you look at the tangent line, then you say, okay, that gives me this as my second guess, and then you put your tangent line in there. This is straight, and it ends up right there, and then you put it in here, and it puts you right there, and you put it in here, and it puts you right there, and you just end up in this cycle between those two spots that never converge. So you don't end up getting a solution. There's other instances where you can, if you got more bumps than this, where you might oscillate between several ones, where you might plug it in and it sends you over to here, and then this one sends you over to there, and then this one sends you back to where you started from over here. I mean, there's all sorts of scenarios where you could get into this cycle through 2 points, where you might cycle through 3 or more points, but get stuck in a loop. And then let me give you one example here where it just doesn't work at all. If you've got, for instance, f of x equals the cubed root of x, so x to the 1/3 power. Okay, I happen to know the graph looks like a sideways cubic curve. If I could draw better, that would actually pass right through the origin like that. Let's try it. I'm gonna guess 1 here and see if it gets me down to the intercept there at 0. I know what the answer is, but let's see what Newton's method does to it. So I need to know the derivative. That's 1/3 x to the negative 2/3. So when I do Newton's method formula here, x n plus 1 equals xn minus the function at xn, so xn to the 3/2 power, divided by 1/3 xn to the negative 2/3 power. Well, dividing by negative 2/3 power, what am I writing here? I think I said it right. So it's a 1/3 power on the top. It's a negative 2/3 power on the bottom. So anyway, dividing by the 1/3 is the same as multiplying by 3. So this looks like xn minus 3 times. Well, I've got an xn to the 1/3 and a divided by xn to the negative 2/3, which is the same as multiplying by xn to the 2/3 power. So it looks like xn plus 1 is xn minus 3 times x n, which is negative 2 times xn. So when I plug a x0 equals 1 in, then x1 is negative 2 times 1, which is negative 2, and x2 is negative 2 times negative 2, which is 4. What happens is this spirals me outward. I plug a 1 in, the tangent line gets me out to negative 2, this tangent line gets me out to positive 4, the next tangent line gets me out to negative 8, and I'm not even going to come close to that thing. Right? So there's situations where Newton's method won't work. But realize that when it does, it generally works really very fast, and it's a very efficient way of finding approximations to solutions of equations.